So let's say that we've got a graph of f prime of x, and that starts at -2, ends at 2, and we're told that it looks something like this. This part is A, this part is B, this part is C. F prime of x is graphed at left if A is greater than B, which is greater than C, at what value on the interval -2 to 2 does f of x, so that's the antiderivative of f prime, have an absolute maximum. Remember, this is A, this is B, and this is C. Well, we're interested in f. Maximum is the increasing C line. We have f prime, so this must be positive, negative. Oops, going from -2 to 2. So we've got positive, then negative, then positive again. So increasing, decreasing, increasing. We have two potential absolute maxima right there. So we could have an absolute maximum either at 0 or 2. The problem is that we can't find numbers here. We just know one thing about this. We know that this is B and this is C, and we know that B is bigger than C. So the thing is that B, we know this area under the curve, that's the of f prime of x from 0 to 1. That's the change in f of x from 0 to 1. And we also know this is below the x-axis. The signed area is negative. So that means this is the negative change in f of x from 0 to 1. So we know that f of x comes down from 0 to 1. And then here, this is a positive change, so it goes back up again. However, if B is if B is greater than C, then that means that the negative change is bigger than the positive change. So let's write down a little bit about that. If B is greater than C, like it says in the problem, f of x goes down more than it comes up on the interval 0 to 2. So if f of x goes down more than it comes up, that means that the point f of 0 is greater than f of 2. We're imagining it something like this. Wherever f of x is here, it goes down a bunch, and then up not as much. That's not a good drawing. Try it again. F of x is going to go down a bunch and then up not as much. So that means that f of 0 is higher than f of 2. So f of x has a relative x equals 0.